In class today, we look at two different situations and we try to come up with two different representations for each. So here are the directions. With your table, create a function for the following scenarios. Model the scenario using at least two different representations: a graph, a table, an equation, a list of points, etc. So in the first scenario, a bear population begins with 50 bears in 2000 and increases by 10 every year. So can you come up with a table, a graph, an equation, a list of points, etc. to represent the situation? The second situation, you start with a colony of bacteria that has 50 bacteria in it, and it doubles every hour. So again, can you come up with an equation, a graph, a table, or something to represent the situation? So most students in class in the first scenario could come up with a table for the bear problem. So let's say that we have time. Put this up here. Let's say X was time or years, and Y would be number of bears. So in year 2000, 2001, or you could start at 1, whoops. You would have 50 bears, and it goes up by 10 each year. So this is pretty easy to see that it's linear. It's going up by 10 each year, and we can write an equation. Y equals 50 plus 10x. It's pretty easy to graph too. You'd have a y-intercept of 50, and it would go up by 10 every year. It'd be linear. So you can make your graph pretty easily. For the second scenario, though, again, a table is pretty easy, and a graph is not so bad either, but coming up with the equation is the problem. So here we have X, we have Y. At time 0, we have 50 bacteria. At time 1, we have 100. Time 2, we have 200. Time 3, we have 400. And so if you graph it, it looks something like this. Question is, how do you write the equation for something that's not linear? So in class we talk about the difference between linear and exponential functions. Linear functions change by a constant number, think add or subtract. Exponential functions change by a constant factor. What are you multiplying by or dividing by to find the next term? So linear add or subtract, exponential multiply or divide. There's two equations that we use to make to write exponential functions. Here's the first one, a times b to the x. A is the starting value, b is the change factor, x is time. Or if it's a money problem with a percentage rate, it's a times 1 plus r to the x. Again, a is the starting value, r is the rate as a decimal, and x is time. So from scenario 2, let's rewrite this equation with our starting value, y equals a to the x, a times b to the x. Like this. Starting value is 50. The population doubles every hour, and x is time. All right, so let's talk about what that stands for. So we know that at time 0, we had 50 in our colony. And if you type that in your calculator, 2 to the 0 power is 1. 1 times 50 is 50. But after 1 hour, we double it. So that's 2 to the first power. After 2 hours, we double it twice. So that would be 2 to the second. After 3 hours, we double it 3 times. So that's 2 to the third power, and that's where this exponent is coming from. So this is exponential growth. So let's take a look at more problems then. One thing I'll ask you on today's assignment is it an example of growth or decay? So take a look at the first example. What's the starting value? It's 100. What's the growth or decay rate? It's 0.5 to the x. And that means it's taking 50% of the time before. Multiplying it by 1/2 each time is going to cause it to go down. So this is an example of exponential decay. So if this b value is between 0 and 1, it's decaying. If that b value is greater than 1, it's going to be increasing or growing. So here we're doubling something, and you can see it's exponential growth. So when I ask you today if it's growth or decay, look at the b value, the number, the base with the exponent. If the number is between 0 and 1, it's decay. If it's greater than 1, it's will be growth. All right. Here's the second equation that we're going to use. Y equals our starting value, 1 plus the rate as a decimal to a certain amount of time. So r equals your rate as a decimal, and to change it, you divide your percentage by 100, or move the decimal place over twice. So here's the function. Starting value is 500. Your rate is 7%, so plus 0.07. and x is time. Use your function to predict how much money you will have in 8 years. So y equals 500 times 1 plus 0.07 or 1.07 to the 8th power. So I'll show you how to type that in, but on the TA Inspired, to type it in, you're going to use the caret key or this key to do to the power of. So once my calculator loads, I'll show you what that looks like. Okay. So we'll come back to that problem in a second. Example 2. The return of a second stock is modeled by this function for years, 350 times 0.9 to the t. So I would ask you on the assignment, what's the starting value? And you should tell me it's 350. So here's your A value, or your starting value. Is this growth or decay? Well, you take a look at this 0.9, and you get 90% of the time before. That's going to be decay. It's between 0 and 1. So it's decay. And then how much money will you have in 8 years? Again, this is almost done. So I'll show you how to calculate that. Okay. All right, so let's go back to that problem. Okay, 500 times 1.07 to the 8th. Here's how you type it in. Let's open a calculator page. Oops. Let's just go here. Okay, so you start with your starting value. It's 500. And then you can put the 1 plus or just 1.07. And then it's to the power of, so here's that caret key right here, and then it makes it an exponent. So after 8 years, you're going to have $859.09 in your account. So $859.09. Let's try the next one. How much money will you have in 8 years? 350 times 0.9 to the 8th. And you'll have $150 left if it keeps decreasing by 90% each year. That's 66 cents. Okay, example 3. The return of a third stock is modeled by this function. First of all, is it growth or decay? You're starting with $1,000, so here's your starting value. This is growth. It's growing at 25% a year. The 1 means it's growing, so this is growth. And again, in 8 years, you just plug in an 8 for your exponent. And you can type that in itself. So today's lesson, the assignment's really short. You're just going to identify what's the starting value, is it growth or decay, and you'll sketch the graph.